Hello, welcome to Quantum Online Academy. This is your Dr. Nagaraju Pendam. In this video, we are going to discuss about one more important science and technology topics. All these days, I am busy with subject of physics. That's why I am able to teach you science and technology topics. But even though now onwards, I have to daily one science and technology topic I have to upload in our YouTube channel. Listen and enjoy. This is a new discovery. From 2024 onwards, this discovery came into the side. What is the discovery? You have to see ALTERMAGNETISM. What is the ALTERMAGNETISM? That is very important. The discovery of ALTERMAGNETISM has emerged as a new class of magnetic order. So it is a new class of magnetic order. These are the magnetic dipoles oriented in upside, 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 the magnetic dipoles oriented in upside. In the same material, the magnetic dipoles oriented downside also is some materials are there. The magnetic dipoles oriented downsides also. The magnetic materials oriented downside also, downside. The magnetic materials oriented downside also is present. Such type of magnetization, we call it as a altermagnetization, altermagnetism. So what is the magnetism and types? You have to see. Magnetism is a force of attraction or repulsion that acts between the certain materials. What is the magnetism? Magnetism is a force of attraction, and Eirsted firstly invented this magnetism in the 18th century. He took the amber and silk and he rushed it. There is a attraction between them takes place. That's why that phenomena we call it as a magnetic phenomena he invented to the world. So what is the magnetism? Magnetism is a force of attraction or repulsion that acts between the certain materials. Mainly the containing of the iron, nickel, cobalt and their alloys. So majorly transition elements in the modern periodic table, these transition elements exhibit the magnetic properties. So mainly this magnetization due to the motion of the electric charges, due to the motion of the electrons, this magnetization is created. Already Faraday told, so changing the electric field creates the magnetic field. This is the Faraday's laws. So that's why the motion of the electrons, the motion of the charge carriers creates the magnetism. Clear? This is the introduction of the magnetism. What is the magnetism? Magnetism is a force of attraction or repulsion that acts between certain materials, mainly those containing iron, nickel, cobalt and their alloys. Due to the motion of the electric charges, so this magnetism is arising. For more centuries, scientists recognized two main types of magnetism, not two main types of magnetism. So the first magnetic type material is the diamagnetic material. The second magnetic material is paramagnetic material. The third magnetic material is ferromagnetic material. The fourth variety of the magnetic material is antiferromagnetic material. The fifth variety of the magnetic material, we call it as a ferrimagnetic material. We also call it as a ferrites. Clear? So these are the based on the application orient: diamagnetic material, paramagnetic material, ferromagnetic material, antiferromagnetic material, ferrimagnetic material or ferrites. For more than a century, so for more than 100 years back, scientists recognized only two main types of magnetism. One is a ferromagnetism, another one is the antiferromagnetism. These are the two main types. What is the ferromagnetism? Suppose you have to apply the magnetic field, the magnetic material, all the dipoles oriented in magnetic field direction dipoles. Such type of all the spins are up. Such all magnetic moments, spins aligned in the same direction of the producing the strong magnetic field. So you have to apply this magnetic field. These dipoles also oriented in the same dipole. So, this fridge magnet, this magnetic material we call it as a ferromagnetic material. Suppose what is the anti-ferromagnetic material? So, these you have to apply the magnetic field, one is up, another one is down, one is up, another one is down, one is up, another one is down. Such type of magnetization is we call it as a anti-ferromagnetism. The neighboring atomic spins point in opposite directions, up and down, cancelling each other fields and resulting no external magnetism is existing, but here magnetism is existing, spontaneous magnetism also existing in ferromagnetic material. In anti-ferromagnetic material there is no spontaneous magnetism. Now the scientists are discovered, so researchers, a third form, that is the altermagnetism, the first theorized in 2019, theoretically they found and they confirmed through the experiment in 2024, right. So now you have to see here what is that you able to alter magnetism. It is rotating or mirror flipping, rotating or mirror flipping. Suppose you have to take this is up, you have to see the mirror in the down, rotating or mirror flipping, rotating or mirror flipping. The crystal pattern matches sides in cancel pairs, leaving no net magnetization, thus bridging the gap between the other two types. The alter magnets, the magnet movements of the neighboring atoms point in opposite directions, one up and the next is down, just like anti-ferromagnetism. So, these opposite spins are cancel each other. So, the material shows no overall net magnetization, no overall net magnetization, but however, so internal electronic structure resembles that of ferromagnets, where electrons have the different energy levels depending on their spin nature. Depending upon their spin nature, there is a magnetism is existing in that. This unusual combination of no net magnetization but internal spin imbalance gives the altermagnets unique property. This is the very important one. So, what are the applications of the altermagnetism? So, what are the applications of the altermagnetism? Altermagnets are also being explored in the quantum computing applications. Their lack of stray magnetic fields helping reduce the magnetic noise, which is crucial for maintaining the quantum coherence or stability of the quantum bytes. So, quantum byte, instead of 0 and 1, we have to use the quantum computing system quantum bytes, that is the qubits we are using. So, that is the first application for the altermagnetism. The another one is Spintronics. These properties make them very attractive for Spintronics, a technology that uses electron spin to store and process information, enabling the faster and smaller and more efficient in electronic devices. We have to use that Spintronics only. So, wide range of materials. One of the most exciting findings is that altermagnetism can exist many types of materials, including the insulators, semiconductors, metals, and possibly even organic crystals. This opens vast opportunity for materials design and new device architecture. This one we have to use. So, not only that, so these key challenges also is there for altermagnetism. Material quality, producing high quality single domain altermagnetic materials is major hurdle. So, fabrication and sustainability, developing the scalable and cost effective fabrication methods is essential to use these materials in commercial electronic or spintronic devices. This includes perfecting the crystal synthesis process for large scale production also. Limited tested materials, so far only a few materials like manganese telluride and chromium antimonide and have all clearly shown altermagnetism effects. Expanding the material library is a current focus on global research. So, now people are concentrating on so these materials, altermagnetism materials. So, now magnetized telluride, manganese telluride and chromium antimonide. So, antimonide, these two elements are possessing the altermagnetism. Now, why ahead? Despite of these difficulties, a rapid progress of discovery, strong global scientific interest, ongoing experimental breakthroughs are all encouraging spins that these challenges can be overcome with time. So, with continued progress in material design and fabrication, it holds the promise to revolutionize next generation information and quantum technology. So, this altermagnetism is a burning research area. Whoever want to do the research in the material science field, because this is a great applications are there in quantum computing and spintronics applications, in electronic devices, in quantum computing devices, we have to use this altermagnetism materials. Clear? So, please, if you have to really interested, you have to do the research in these areas. So, please share and like our video. So, we will discuss so many science and technology topics in our YouTube channel along with our physics subject also. Thank you so much.